Good day, everyone. So today we shall be diving into simple electrical wiring topic. It is an introduction to the fundamentals of electrical circuit, the essential tools for this circuit, and the common wiring material. So we shall be learning this concept. Let's dive into this. So first of all, what do we understand by electrical circuits? Okay, so an electrical circuit is a system comprising a load, a power source, a switch, and connecting wires. So these four components make up electric circuit. The load, power source, the switch, and the connecting wires form an electric circuit. So it's of two types. We have the series electric circuit and we have the parallel electric circuit. For either of them, you must find these four components in it. Now, what makes us have the two types is the arrangement of this load, okay, among the components. Okay, the arrangement of this load among the components determines whether it's going to be series circuit or the parallel circuit. Now, for series circuit, when the loads are connected end to end, as you could see here, this bulb now is a load. The appliance is what we refer to as a load, either your fridge, your ceiling fan, your light bulb. But right now, we're making use of light bulb as an example of load. Now, when you connect the load end to end, as you could see, using the electrical connecting wires, okay, when you connect them end to end, side by side, then you call that circuit series circuit um, connection. See these two bulbs now, they are end to end. On the other hand, the parallel circuit is when the loads are connected side by side. You see the load here. In this case, the two bulbs are connected side by side, unlike the series where they are connected end to end. So when they are connected side by side, it's referred to as what? Parallel circuit. In series circuit, what you observe is that when one of the bulbs stops working, automatically the second one or any other one that is in series will stop working. Unlike the parallel connection, when one of the bulb is faulty, it will not affect the other bulb. Okay. Lastly, in series connection, you could see this in this red object moving represent the flow of current. Now, the same current flows through the first one, the first bulb and the second bulb, and it goes round. So it's the same current that goes through each of the load for series connection. However, for parallel connection, when the current is being supplied by the power source, in this case the battery, when they get to this point, they split into two. You could see one goes to the first bulb and the other one goes to the second bulb. Look at the splitting now, you could see there's a splitting. So different current enter the two load when they are in parallel connection, but the same current enter the two load when they are in series connection. So those are the major differences between series circuit and parallel circuit. It's just the arrangement of the load. Now let's talk about the series circuit again in details. Like I said before, the same current that is flowing from the power source, this is the power source here, this is the switch, allow the current to continue to flow or to disconnect the flow of current. Now, whenever it is closed, whenever the switch is closed, the current can flow through the wire. This black thing are called the connecting wires. You go to the connecting wires and then we take the current to the bulb and the next connecting wire takes to the other bulb. This is connection. The bulb are connected end to each other and then the same current flows through. Okay, so they form a single path for current flow. Current can only flow in one single path, like I've said earlier. Now, the key characteristics is that any component in series break, any break in a component in a series, it affects the other one. Now, if there's anything that happened to this bulb here, automatically, even if this battery is working, this other bulb will never turn on. That's because of the series arrangement method. Okay, So that's one demerit about series arrangement. When one of the loads is faulty, automatically it affects the other because the current can no longer flow around anymore. Okay, so in series connection, when one break, it affects the entire circuit flow. Okay, so all that component will stop working. So on the other hand, for the parallel circuit, so in parallel circuit, we say that the loads are arranged side by side, as you could see here, in the sense that there will be a junction. You see there's a junction here where the current split into two, and this place two. All right. So the currents entry into the each of the load are not the same. So when the current is being supplied by the battery and it goes to the connecting wire, when it get to this junction, it's split into two. So they have different current entering them, but then the voltage across parallel connection is the same. For series connection, I didn't even remember to mention that. For series connection, the voltage across each of the load is different. The voltage across this load here, this first bulb here, is different from the voltage across the second bulb here. But for the parallel connection, the voltage across the two bulbs, which we are referring to as load, are not the same. Are the same here. But for series, they are not the same. But for parallel, they are the same. The voltage are the same. Because voltage potential different at times. So that's the major difference between series connection and parallel connection. For series again, I want to reiterate the same current flows through each of the bulb, but different voltage, which we call potential difference. But for parallel, different current flows through each of the bulb, but the same voltage is across them. One good thing about the parallel connection is that when one of the bulb or one of the load is faulty, it does not affect the other one because it's not the same current. So imagine that this current is being supplied, okay, and this is faulty. Of course, it's only going to affect the fact that the current here will not be able to turn this on because it's faulty. But the other current that has been splitted will go on to turn this other on. So the fault of one load does not affect the entire circuit in parallel connection. That is summary of what we are saying about the types of electrical circuit, the series and the parallel. Now, we have what we call the wiring tools and materials. That's what we use in making the electrical circuit. Now, the first one here, the first tool here is called the plier. Pliers are used for cutting cables and twisting wire end to end. We could see here, these terminals where these wires are connected, you will need pliers to twist the wire and then connect it end to end. Even at this point where junction is created, you will need a plier to twist the wire together so that they can form this junction here as well as this place. So we use the plier in cutting cables. So sometimes you need to cut a cable so that you can reconnect it to another wire. Okay. So you use to cut the cables and twist wire end to end together. Then we have what we call a screwdriver. The screwdriver, as we see this person holding it here, is used for tightening screws in blocks and fixing accessories. Okay, so when you have to tighten screws, okay, you make use of what the screwdriver. We mentioned some of the usefulness of screwdriver in our previous lessons. So I will enjoin you that you go to those lessons and watch the video again. Then we have what we call the clips. We use the clip to fasten electrical cables securely to wall or ceiling. Okay, so when you are reason to hold the wires with object, that's where the clip comes in. Okay, when we go back to this place now, maybe you want this connecting wires here to be held to the wall. All right, you use a clip to hold it to the wall, okay, so that it does not form a loop or look scattered or kept on the wall. So that's what the clip does for fastening electrical cables securely to wall or ceiling so that they do not fall off. All right. Now let's talk more of these two. We have what we call the hammer. The hammer is not a new tool. We use this to drive nails through clips into the wall for cable fastening. So there are times where you need to use this, where you need to drive nails into the wall, just to probably to hold some of the electrical appliances too. That's where the hammer comes in. And we have the mallet. The mallet, oh, this is the picture of a mallet, look almost like the hammer. Usually we use this to straighten out kinks or hunches in wire during surface wiring. It's not as hard as that of hammer. So when you want to do a little driving with a little pressure, want to apply a little pressure, you make use of the mallet, all right, in order to avoid breaking whatever you are driving in. Then we have the drilling machine. We talk about drilling machine too in our previous lessons. So we use this electrically for making holes in the wall. When you have to make holes in the wall so that you can hang some of your electrical appliances, you make it with a drilling machine. So you use it in making holes in wall or wooden blocks. That's what the drilling machine does. All right, and we also have another one that is screws. The screws is what we use the screwdriver for. Okay, we use screwdriver to drive in screws, okay, into the wall, just to hold cables too. All right, and while we use the hammer to drive in nails, we use the hammer to drive in nails, and we use the screwdriver to drive in screw. That's the difference between the nails and the screw. So the nails is being driven by hammer, while the screws is being driven by screwdriver. Then we have what we call the tester. We use the tester to check for live current flow. If you want to be sure that there is current flowing in a circuit and you don't want to be electrocuted, that's where you make it of the tester. So when you use the tester, okay, when you use the tester to touch the wire and it indicate red, that means there is life, there is current in that wire. So and the last one is cable. Okay, um, of course cables are insulated so that it does not electrocute. So we use the insulated cables or wire in connecting load, okay, in connecting load to power supply, like we saw in our electric circuit type. Okay, let me take us there again. So here you could see these are what we call cable. This black, okay, they are cables that we use to connect the load to the power supply, okay, and they are insulated because we do not want it to electrocute any man. All right, so those are the materials we use in electricity or for electrical circuit work. All right, now let's talk about electrical accessories. Electrical accessories are devices other than lighting fittings. That means they are not lighting fittings like your lamp or your bulbs. So they are devices rated for maximum voltage current to prevent overheating or failure. Okay, so they are devices that are rated for maximum voltage current. That means on them it will be written the amount of voltage that can pass through them or the current that can pass through them, so that they do not get overheated or get damaged. Okay, so they are devices that are used in electrical circuits aside from the bulbs to help the electrical fittings more effectively. Okay, now one of them is called the switch. We use the switch to control circuits stably and reliably. So if you want to turn on or turn off the flow of current, you make it a switch. And we have the lamp holder. The lamp holder is used to secure lamps and ensure proper contacts. Then we have the wall socket. The wall socket provides The wall socket provide a space where power can be connected. Okay, so it's a space for power outlets. Okay, a space for power outlet. And some other ones are the ceiling rows, the joint boxes, the fuse boxes, the socket plugs, the connector, and the adapter. So let's talk about these electrical accessories one after the other. So for the switch, it has different types. So we have the wall switch. This is an example of a wall switch. Like we said, it's a rectangular plate with a single toggle switch. So when you turn it on, okay, whatever it's meant to do will start working. Okay, maybe it is your light bulb or your ceiling fan, whatever. So it's meant to turn on or turn off the flow of current, and it's connected to the wall. It's a rectangular shape, as you can see here. You would have come across one of them in your um, areas. We have what we call the switch socket outlet. This is it here. So it's also a rectangular plate, as you can see here. It's a rectangular plate that is connected to the wall, and it has a switch and also three pins where you can connect your plug. All right. Then we have the lamp holder that we mentioned earlier. This lamp holder, we use it, it's a circular component. Okay, as you see here. We have different types now. They don't come in circular form only, but this is a circular type. It has a central socket for light bulb. So this way you connect this socket where you connect the bulbs. That's why we call it lamp holder for holding bulbs. And we have the joint box. This is the joint box here. The joint box is also a small circular box, as you can see here. Okay, for connecting electrical wires. So inside it, you connect different electrical wires to form a junction. And then the last one is the ceiling rods. This is ceiling rods here. The ceiling rods is a component for mounting light fixtures to the ceiling. If you want to connect light, the wiring that is coming from the light goes through this space here. All right. So those are the other common electrical accessories that we have, and they are rated for their maximum voltage. So when you are making use of them, you must consider the their their rate that have been written on their body. If you don't consider it, it might get damaged or get destroyed. So electrical accessories help in the connection of electrical circuits and make it smoother, make the flow of current smoother and better. All right. So today, what is our key takeaway today? We have learned basic circuits. We have learned two circuit arrangement, that is series and the parallel circuit for safe wiring, and we're able to learn the right tools for use for connecting the circuit. We're able to mention some of the tools like our pliers, our screwdriver, our hammer, our mallet, and we mentioned our electrical accessories that we said that they are devices for electrical circuit other than light bulbs, and they are rated for their maximum voltage. So we're able to mention some of them, like our lamp holder, our switches, and so on and so forth. So it is very important that we familiarize ourselves with all of these electrical accessories, and then to master them so that we can carry out our electrical wiring project efficiently and effectively. So I will be doing the cutting here today. I hope you have learned something from today's lesson. Thank you for watching and have a wonderful day. Bye for now.